This is a video from section 1.3 in a linear algebra class. Let's take a look at 10a. It says, express each column vector of AB as a linear combination of the column vectors of A. Let's take a look at a specific example to get a feel for what this problem is asking. Let A be the 2 by 2 matrix A11, A12, A21, A22. Let B be the column vector B11, B21. Now, I want to take a look at AB. This is the matrix A11, A12, A21, A22 times the column vector B11, B21. Now, this is equal to the column vector where the first entry is A11, B11 plus A12, B21. The second entry is A21, B11 plus A22, B21. And we could break that up into the column vector A11, B11, A21, B11 plus the column vector A12, B21, A22, B21. And so if we look at the first column vector, notice how the B11 is common to both entries. Well, we could pull that out in front, and we can take B11 times the column vector A11, A21. Then I'm going to go plus, and then notice how the B21 is common to both entries of this second column vector. And we could pull that out and take B21 times the column vector A12, A22. Now, look at what we did. We took the first entry of the column vector of B, right? And then multiplied it by the first column of A expressed as a column vector. And then took the second entry, B21, and multiplied it by the second column of A expressed as a column vector. That's basically what we did down here. Let's see if we could generalize that. Now, let A be an M by R matrix, and let B be an R by M matrix. Now, you might ask, well, why did I do it that way? In 10b, we have to look at the product BA, and for BA to make sense, the columns of B have to match the rows of A. And for AB to make sense, the columns of A have to match the rows of B. So this has to be defined in this way. Okay? Now, so again, let A be an M by R matrix, and let B be an R by M matrix. Let C1 through CR be the columns of A. Let B1J, B2J, all the way through until BRJ be the entries of the jth column of B. And that's where J is between 1 and M. Why is it between 1 and M? Because if we look up here, B has M columns. All right? Now, I'm going to take the matrix A times the column vector B1J, B2J through BRJ. Now, I'm expressing A in terms of its columns. So notice how I have the matrix where C1 is the first column of A, C2 is the second column of A, and then CR, I'll put a little dotted line there, CR is the rth column of A. And I'm going to multiply it by the column vector B1J, B2J through BRJ. And we're going to do something quite similar. Now, C1, essentially, I'm going to take B1J times the first column of A. B2J times the second column of A. BRJ times the rth column of A. And that's what I did. So notice, B1J C1 plus B2J C2, all the way through until BRJ CR. And C1 through CR can be written as column vectors, right? And that's the idea. Now, in part B, it says express each column vector of BA as a linear combination of the column vectors of B. And so we're going to let B be an R by M matrix and let A be an M by R matrix. So let D1 through DM be the columns of B, and let A1J, A2J through AMJ be the entries in the jth column of A, where J is between 1 and R. So we're going to look at B times the column vector A1J, A2J through AMJ. But that's equal to the matrix where the first column is D1, second column is D2, on and on and on. The mth column of B is DM. And I'm going to multiply by the column vector A1J, A2J through AMJ. And so I'm going to take the first entry, A1J, and multiply it by D1. And D1 is again expressed as a column vector. Then I'm going to take A2J and multiply by D2. And we're adding, right? And I keep going in this pattern, and then I stop when I get to AMJ. AMJ gets multiplied by DM. And that's how we do part 10B. And that'll conclude this video for section 1.3, I believe, and we did problem 10. Okay, thank you.